Cool. All right, as mentioned, I'm going to talk about securing passwords, and in particular, going to talk about a tool that we've been using. My name is Justin LaRose. I'm an engineer over at Comcast, and we, about a year ago, started looking at a tool by HashiCorp. Those familiar with like Vagrant and Console, it's a secret management tool called Vault. So, being that I'm a Comcaster, I decided to use a lot of TV to kind of pull on your emotional heartstrings to think that my talk is awesome because these are your favorite shows. So, why did we pick Vault? So, I think this is a problem a lot of engineers are trying to solve, and that's securing certain pieces of information that you just don't want public visibility for. So that's secrets such as passwords for your database or your keys for your SSL certificates, your API access keys, things of that nature. Things like that you would never want to check into some sort of source control. And we started exploring options very early on because it's a common problem that you face. And we looked at just using regular encryption. And there's also tools out there, one called KeyWiz by Square. There's also, Amazon does some additional encryption tooling, what's it called, KMS. So we kind of narrowed in on Vault just because it wasn't tied to a specific configuration management tool. So we use a variety of configuration management tools such as Puppet, Ansible, Chef, and things like that. And with Ansible, because it's an API, it's pretty portable as far as being able to use it flexibly with multiple technology stacks and different configuration services. So a little background on what I do. I work in a group of engineers that developed the X1 platform, which is a cloud-based television guide that Comcast develops. And in our infrastructure, we have a lot of ephemeral VMs. Like we constantly destroy and bring back up VMs. And with that, you need some automation around retrieving your keys and other secrets that you would need because these aren't static based systems. So one thing that you might encounter, if you just go on GitHub right now, like just do a search, you'll see things such as AWS access keys that you could just pull out and be able to use. And this is what we're trying to prevent, where your configuration management isn't being stored in your source control. So, as I mentioned, Vault is a system that it's an in-house system that you host. So it's not something that's hosted by an outside company, but it's something that you could stand up. They did begin to offer enterprise services just recently. So if you wanted to pay some sort of monthly fee, you could get more support through HashiCorp. But fundamentally, you stand up an environment in which the Vault service is running. And your service makes API calls to an endpoint. And the way that the secrets are stored is through a context path system. So in this example up here, you'll see that there's this version 1 of the API, and then there's a context path that has secret network HBO Silicon Valley. And with that endpoint, you make a call to this URL to pick out a secret that's stored under Silicon Valley. So this will kind of clear it up a little bit more. So Vault offers a command line tool where you can, from the command line, do a read to that endpoint. And this is the return response. You'll get back a key value set. You can store multiple key values. So in this case, I just picked 2 pieces of information. And then there's a refresh interval, which I'll get to a little bit later. So in this case, you've returned back to you the key and access key for talking to the AWS APIs. So that's the command line. But then here's what an API call is. And in this example, you have a vault token. And that vault token can be retrieved in a variety of ways. And I'll get to that shortly. But then in the response, you'll get that same information that I showed earlier that you would get from the CLI. So how do you obtain this token here that you pass in the header? Vault offers what they call authentication backends. And these authentication backends ultimately allow you to retrieve a token in which you can then use to retrieve the secret information. These probably are majority familiar to. The app ID is something that's internal to Vault, but LDAP, GitHub tokens, TLS certificates, username and password, and then everything ultimately becomes a token. And that's the token that gets passed in your API request. These tokens have certain metadata around it. It's leased data. And this particular set of parameters that I kind of will go into a little bit more detail is sort of the kind of cool features that Vault offers. First, there's time to live. So if you have a token, you could set a time to live on that token, meaning that this token is only valid for a certain amount of time unless you make a second call to renew that token for reuse. And then there's explicit max time to live. And an example of that is where you would want a token to live for a certain amount of time. So let's say 5 minutes. So instead of having a token that has continual renewability, you might want this token to be only used for a set amount of time because it's going to be shared with a lot of users and you don't want it to compromise your system. Then there's also the option of number of uses, renewability, and then policies. One of the common problems that comes with a system like this is sort of like the chicken or the egg sort of situation. And it sort of makes me think of this quote from a well-known rapper: "Why do I need ID to get ID? If I had ID, I wouldn't need ID." How do you have a token that you can freely pass around and not have to worry about any vulnerability? So they set up a certain feature called the cubbyhole in Vault, and I'll explain that very briefly. So you guys might be familiar with this. This takes you back to kindergarten days where this is a cubby, right? And in the cubbyhole sort of workflow that Vault offers, you would create a temporary token. This temporary token would either be limited by number of uses, let's say 1 use. So once it's used, that token's expired, can never be reused again. This token would be utilized to retrieve a permanent token. So the temporary token can be freely used because it will be expired after a certain amount of uses. You don't have to worry about any vulnerability. So with this temporary token, you are able to retrieve this permanent token. This permanent token is what's stored in the cubbyhole. And after you have the permanent token, you can then expire the temporary token. It's no longer usable. And then you take your permanent token and then retrieve the secret. So that's one of the workflows that they offer that can be very helpful based off of your use cases. There's also a template-in system that's a common use case where if you want a template, make a template of your configuration management, you could utilize something called console template. It takes in a YAML format, and you could make calls to Vault using a template system. It also, Vault has multiple software libraries available to it. So here's a list of some of the official software libraries that are available. There's Go and Ruby, and then there's some community libraries that are built around the APIs that Vault makes available. So that's pretty much my presentation. Is there any questions?
With the Vault CLI, does it have tab completion for the paths that you have stored when you go Vault read?
No, it doesn't have tab completion, but you can do listing of your paths. So like rather than just do a read, you could do a Vault list and then a path, and it would return to you similarly how your directory structure would be on like a file system. And then you could go down the tree that way.
You talk about the benefits of being able to seal your Vault and unseal, and how does unsealing work?
Sure. So when Vault is initialized, it comes up in a sealed state. And the reason for that is it allows for, in case you did get exposed somehow, it's almost like having a red button to hit to lock down the system from any other access to Vault. So when Vault's at first initialized, it's in a sealed state, and then there is 5 keys that are sharded there's one key that's sharded into 5 separate keys. And the reason for that is that one of the common practices is that these 5 keys are distributed amongst team members. And with these 5 keys, team members can then unseal the Vault. So this prevents like a renegade employer leaving the company and then gaining access and letting out all the passwords. It requires 5 different keys, or I'm sorry, it shards it into 5 different keys, but you actually need a minimum of 3 keys to unseal it. So it's almost like the nuclear football where you have to like turn 2 keys to like get access type of thing. Does that answer your question?
Do you guys use one instance of Vault for all environments, or do you have one per?
So currently we're using Vault as a department, and the way that we're organizing the keys that are available is that you can limit access using policies. So if you could imagine secret and then the HR department, secret / the accounting department, you could limit access for tokens so that only the HR department can read anything that's below that particular endpoint. So we have one for our department for the different groups of engineers, and it's set up in a like high availability setup where it's in multiple data centers, and has like a R53 load balancing in front of it. There was a question here.
Yeah, kind of building on that. Are you running it on top of the console?
So I didn't go into this, but the data that's stored in Vault is stored in a variety of data storages, variety of data storage tools. One of them is Console, and we are using Console for the data storage. It's using Console's key value component.
And have you seen any issues with stability or availability there?
I feel like it works pretty well. We explored, you could also use Zookeeper as a key value storage. Our company does use Zookeeper in a lot of variety of use cases. We haven't seen much problems because one of the details that I didn't go in is there's a leader election component to this. So let's say we have 3 Vault servers. One of them, Console would go through a process in electing a leader, and all requests that comes into Vault, no matter which node it hits, will go to the leader node. And I feel as though that leader election has provided enough high availability for us to feel confident that there's we won't have problems.
Roughly how many instances of
So they recommend having like an odd pair of nodes so that you don't run into like, it's easier to do the leader election. Right now we have 3.
Can you use policies at the app ID level? So like, they use app ID, so only staging app IDs?
Yes, so when you create a app ID setup, you associate it with a policy, and that's what we do. We also do that with the LDAP users. So we have an internal LDAP authentication system, and you could scope it based off of the group that's been defined in your LDAP. So like members of the ops team might belong to a group, and you could scope out the policy that the users have access to based off of that. Okay, doesn't look like there's any more questions. Thanks.